Down a chair. Next will be a table. Okay, today we are doing chapter 1-3, and we're talking increasing, decreasing, and constant. How many of you guys have ever ridden a roller coaster? Or have seen a roller coaster? Okay, when you first get on the roller coaster, everybody gets strapped in. And you get strapped in. The very first thing that you do is you start to slowly exit the entrance area, right? And you're going along at a very level slope, yes? Then all of a sudden, it's a slow grade going up. Would you agree? Click, 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 click. And then you get to the top of the peak, and then what happens? You stop for a slight moment, and then go all the way down, right? And turn and twist and all kinds of things. You with me? I want you to visualize increasing, decreasing, and constant as a roller coaster ride, okay? This is read from left to right, and it's on your x values, which is your domain. It's on your x values, which is going to be your domain. Constant means it's level and unchanging. Increase means you're going up the hill. Decrease means you're going down the hill. And you're doing this from left to right, okay? Now, with that being said, we're going to have some maximums and some minimums. There's what we call a maximum and a relative maximum. Now, a maximum over the entire graph is going to be the tallest peak or the largest mountain. You with me? In the graph. That's going to be the overall maximum. The relative maximum is I'm going to give you a region of x values, let's say between -4 and +2, and I want you to give me the maximum value between -4 and +2. Does that mean it has to be the maximum value over the whole graph? No, it means for the region -4 to 2, it is the highest part of the graph. Do we understand that? Then we have what we call minimum and relative minimum. Same exact concept, except for it's the lowest mountain, the lowest valley. You with me? Lowest valley, dip. Or it's the relative to an interval of the lowest valley that we have. Now, the way I like to give an analogy of this is going to be mountain ranges. The mountain range, the highest elevation in the United States, could be very different than the highest elevation in the world. Would you agree? It's not going to be exactly the same. The lowest depth in the United States is not going to be the same as what the lowest depth in the entire world on Earth would be, yes? Okay, so those would be an example of minimum, relative minimums, or relative maximums. Any questions on relative mins and relative max versus regular max and mins? Okay. Now, you have to have points, and that is something I want you to understand. These are points. When you are doing increase, decreasing, and constant, you're always doing it on the x values. But the problem is they look like ordered pairs rather than intervals. But they are intervals for the simple fact that you are always doing it on an open interval. You are always doing it on an open interval. And here's why. You are only using parentheses. Let's say I have an interval from me to Ethan and then from Ethan to Luke. Ethan is shared in my interval and in Luke's interval. How can he be included in mine and be included in his? So instead of putting brackets, what you do is you automatically just use parentheses over the entire thing. Do we understand that? So we don't use brackets, we use parentheses to indicate the interval, okay? Maximum minimum values are needed because this is where you are changing directions, okay? So whenever I give you a graph, the very first thing you want to do is you want to find the point on the graph where the direction changes from increasing, decreasing to constant, and vice versa. Okay? So the very first example I give you is this one right here. And I say, okay, I want you guys to find the intervals in which it's increasing, decreasing, or constant. So the very first thing you're going to do is find the points on the graph where it changes direction. Can you tell me where the points on the graph changes direction here? What is the first ordered pair where it changes direction? -3, +2. What's another point on the graph where it changes direction? Sable. Yes. Now, listen whenever I say this. Remember I said you read this from left to right on your x values. So whenever I am touching my graph, what is the first possible x value that I land on my graph? Negative infinity. At negative infinity, are my y values increasing as my x values get larger, or are my y values decreasing as my x values get larger? Meaning, if I put myself on this graph, am I going uphill or downhill? I'm going uphill, so therefore at negative infinity, I am going to start to increase. Do we all understand that? At which x value do I stop increasing? At -3. At -3, what happens to my corresponding y values as x gets larger? It stays the same. So at -3, I turn constant. And when do I stop turning as a constant y value? I stop increasing, or I should say I stop being constant on the values -3 to 6 for x. Do we understand that? At the x value 6, what happens to my corresponding y values as it gets larger? It decreases. So at 6, I decrease. And when do I stop decreasing on my x values? All the way to infinity, my y values get smaller. Do we understand that? Yes or no? Make sense? Okay, so let's go ahead and do that again. This right here, I'm sorry, it should have an arrow on the end of it. So same exact things, increasing, decreasing, or constant. What I like to do is we already have the ordered pairs on this one. So I just want you to go ahead and put yourself on the lovely little curve. Okay? So where did I first start touching the curve on my x values? What's the first x value? I'm sorry? Nope. -10 is whenever I first touch the graph. So as I'm chugging along at negative infinity, I do not touch the graph until x equals -10. Do you understand that? So at -10, am I increasing or decreasing? The y values are going down, so at -10, I'm decreasing. And at what x value do I stop decreasing on my y values? At -2. And then at -2, I change directions. And what's happening whenever I change directions? I'm increasing at -2. And when do I stop increasing on my x? At 2. And then at 2, what's happening? I'm constant at 2 until what x value? And then at 5, what happens? Well, how do I go ahead and put another area there? Put U for union. And at 5, I start to decrease to where? 7. And then what happens at 7? Put another U for increase. So 7 to where do I stop increasing? Infinity. Do we understand that? Yes or no? This is just like problems 1 through 4 on homework. Do we understand problems 1 through 4 on the homework so far? Excellent. Okay. Then the next set of instructions is going to be doing even and odd, as well as doing this graphically. Now, when you have even and odd functions, an even function back in Algebra 2 was whenever you were able to take the graph and fold it down the center of the graph and it lays symmetrical over the y-axis on the other side of it. Do you remember that? That was graphically how you could determine if a function was even. Algebraically, what happened was when we took x and replaced x with -x, that it turned out to have the same y value. One more time. When I replaced x with -x, that it had the same exact y value, in other words, height. And you can tell that it does have exactly the same height. So what this means is algebraically, to be an even function, you are proving that f of x is equal to f at -x. Okay? To be an odd function, then you're going to have symmetry across the origin. Now, when you have symmetry across the origin, you're folding it twice, once over the y-axis and then over the x-axis. Do you remember that from Algebra 2 and geometry? So you're folding it over the y-axis and then you're folding it down over the x, meaning the point that was in quad 1 now is in quad 3. The point that was in quad 2 is now in quad 4. Okay? It goes diagonally. It goes diagonally whenever you are an odd function. So an odd function algebraically says that f at -x is now equal to a negative being distributed into the function. So what we're going to do is we're going to do a problem like you're expected to do tonight on site homework. I'm going to show you how to do these. So the first thing we're going to do is it's going to say, all right, I need the relative max, the relative min, decrease and increase and constant. And now we're going to prove that this thing is going to be even or odd. So what I'm going to tell you guys to do is Google a graphing calculator, because our graphing calculator app is still not working. And the graphing calculator app that I want you guys to use is going to be Desmos. So if you go to Desmos, okay, you guys can just watch me do it today. You don't have to worry about participate. You can just watch me do it. Okay, can you read off the example that you have to do? So when you get to Desmos, this is what you have. You're going to pull up this little keypad down here on the left-hand corner, and the first one is going to be what? 3x, a to the b right here to the fourth. Then get out of there, and then what is it? Okay, hit enter, and then go ahead and minimize the keypad area. Okay, so there is my function. Do we see this, yes or no? Okay, now immediately what it's going to ask you to do is to find your relative max and relative mins. In this problem, all you have to do with Desmos is literally come over here and click where you think it's going to be at. Do you see that? 0, 0. What is that called? What would you label that as? On your paper, in your notes, what would you label the point 0, 0? Relative max. Exactly. So you're going to put the ordered pair 0, 0 under relative max. Then I'm going to have a point down here. What is this point? -1, -3, and what is that? I can't hear you. Relative min. And then I have another one where it changes direction. And what is that point? 1, -3. Do we see that? Now, what I'm going to do is I'm going to put this over here. And I'm going to try, yep. Then I'm going to put that over there. Okay, so what this means is that under relative max, I'm going to go ahead and put 0, 0. Relative min, I'm going to have -1, -3, and 1, -3. Those are not intervals. Those are points. And it's super, super important that you understand that that is a point, David, of an atom. Okay? Now, at this point, we need to decide decreasing, increasing, or constant. So I'm going to put myself on my roller coaster curve here, yes? At what point, what is happening at -infinity? Have I touched my graph yet? I have touched my graph and I am decreasing at -infinity. When do I stop decreasing? On what x value? On the -1. What happens at -1? I start to increase at -1, and then what happens? It stops increasing at 0, and then what happens at 0? I put a U and it starts decreasing at 0 until when? At +1, and then what happens at +1? I start increasing to where? Positive infinity. Now tell me, do I have any constant parts here? Do I leave it blank? No, because I have to acknowledge it, that I know that there are no constant terms. So what am I going to put there? None. Do we all understand that, yes or no? Make sense? Okay, now I want you to look at this graph. If I were to fold that on the y-axis, would it lie directly on top of the other arm of that function? So what are you telling me that you think this is, an even or an odd function? You think it's an even function. You think it is even. So how do I algebraically prove that it is even? The way you algebraically prove the even functions is you're going to prove that f of x is equal to f at -x. Do we understand that? So f of x is given to be the 3x to the fourth minus 6x squared. Yes? So to do f at -x, I'm replacing every x with what? -x. Yes? So tell me, what is -x times -x times -x times -x? X to the fourth. So this gives me 3x to the fourth minus, what is x times x? Minus 6x squared. Now my question to you is, do the green and the red boxes match 100%? Yes. You know what I just proved? I proved that this is an even function. You are either even, odd, or neither. You cannot be both even and odd. It's one or the other. Since I've proven that this is an even function, I do not have to prove that it is not an odd function. Am I clear on that? So let's go ahead and do the next one. The next one is the absolute value. So I'm going to come over here, and I'm going to delete this out. I'm going to pull up my key bar here, and I'm going to start typing that in. That's going to be a negative absolute value of x plus 4. Get out of there. And this is going to be minus the absolute value of x plus 1. And there that is. And I'm going to make that go away, and I'm going to pull this up so that I can see it a little bit better. Do we see that? Yes or no? Okay, so there's going to be my graph. Now, here's my question. Do I have any relative maximums? True mountains or true valleys? Do we all understand that there are no true mountains or valleys? I cannot see a true mountain, so this is none, and this is none. Do we understand that? Do I have points on the graph where the direction may change? So they're points of interest. Yes. And what do you think those direction points of interest would be? -1, what would that be? -1, 4, and -4, 4. Would you agree? It's 3, sorry. So my points of interest are going to be -1, 3 and -4, 3. Those are supposed to be -3, right? Yes. Can we see that? I need those so that I can look at my increase, decreasing, and constant concepts, yes? So what happens at negative infinity? When do I touch my graph? Do I touch it at negative infinity? Yes. So what happens at negative infinity? I'm starting to increase. So at negative infinity and increasing, and when do I stop increasing? At what x value? -4. I don't want the y value, I want the x value. Okay, then what happens at -4? I turn constant at -4 to what? -1. And then what happens at -1? I decrease to where? To positive infinity. Do we all understand that? Why is it positive? Very good question. Because as I am right here, if I'm at my y-intercept right here at 0, -5, as x gets bigger, what's happening to every one of my y values? My y values are getting smaller and smaller and smaller. Does that make sense? So whenever I was over here at negative infinity, my y values kept doing what? As I got bigger. As my x's got bigger, my y's got bigger, yes? Then between -4 and -1, as my x's increased, my y's stayed the same. And then as my x got past -1, my y values kept dropping as my x values got larger. Do we understand that? So increasing, decreasing, and constant are comparing your y values as x gets bigger. You with me? Okay? All right, now, according to my graph, can you tell me, does this have an even or an odd symmetry? Why neither? Guys, it's kind of wobber job right in the middle of my graph. It's not in one quadrant. It's not in the middle of an axis. It's all over the place. Would you agree? So because of that, this means that it's probably not going to have any symmetry whatsoever. So I have to prove that it's not even and that it's not odd. So how do I go about doing that? Well, I'm going to write down what f of x is. F of x is this right up here. So there's my f of x. Now I'm going to do f at -x. So I'm going to replace x with a -x. Are those the same? Are my black box and my red box the same? No. So guess what I just proved? It's not even. So this means it's not even. Okay, so now I have to do negative in front of the function. So negative parenthesis, negative x plus 4 absolute value minus x plus 1 absolute value. So when I distribute that negative, it turns out to be a positive absolute value of x plus 4 plus a positive x plus 1. Do my green and red box equal each other? No. And why am I comparing green and red? Because to be odd, f at negative x, which is the red box, has to equal negative f times x, which is the green box. Do they equal each other? No, they do not. So that means this is a neither problem. This is a neither problem. Do we understand that? This is a neither problem. Are we good? Okay, let's do this again. X cubed minus 5x. So I'm going to go over here with my graph. Make this x cubed minus 5x and hit enter. Okay, what do you think? Off the top of your head, what do you think the symmetry is going to be of this thing? Why odd? If you fold it over the x-axis and fold it over the y-axis, it's going to lay directly on top of each other. Do you see that? This hump, if I fold it over, will be directly underneath of the other hump. And then if I fold it horizontally, fold a hot dog and fold a hamburger. You with me? How many of you have heard fold a hot dog and fold a hamburger? Hot dog is over the y-axis. That hump is going to be right underneath of the other one. Then if you fold it hamburger, it's going to lie on top of each other. Do we understand that? So I'm telling you that this is going to be an odd function. So how do I prove that? To prove that it's odd, that's going to be f at negative x is equal to negative f of x. So f at negative x, that's going to be negative x cubed plus 5 times negative x. What is a negative times a negative times a negative? A negative x cubed. And what is 5 times negative x? Negative 5x. So that's the first part of the equation. Now let's do the second part of the equation. What is the second part of the equation doing? What am I doing with that negative? What am I going to do with the negative? I'm going to distribute it. So negative parenthesis x cubed plus 5x. So that's going to give me a negative x cubed minus a 5x. Do my boxes equal each other? Yes. So what did I just prove? That it's an odd function. So I proved that it's odd. Do I have any relative maxes or relative mins? Yes. Does anybody know what they would be? That's an ugly number. Is that okay? Absolutely. It's totally fine for that to be that way. What about this one? Yes, that's totally okay. So I have a max and I have a min. Do we all understand that? All right. I'm going to get off of the calculator and we're just going to keep on going with our problems here because I feel like the part that always gets my students is the even and odd. Okay, I want you guys to do the next two problems by yourself and show me which ones they are without the graph and do it algebraically. How are we doing? Okay, let's be smart about this. X squared. What does an x squared parent function look like? It looks like a U, okay? 3x squared minus 2. 3x squared minus 2, you know what that looks like? A parabola moved down 2 units, doesn't it? So what function, which one do you think this is going to more likely be? Odd or even? It's probably going to be even. So would you do odd first, or would you check the even first? Yes. So I'm thinking this is even. So I need to check that f at x is equal to f at negative x. Correct? Well, here is fx. So all I have to do is f at negative x. So that's going to be 3 parentheses negative x squared minus 2. Well, what's a negative x times a negative x? Positive x squared. So do my boxes equal each other? So what did I just show you? It's an even function. Do we understand that? Make sense? Okay, this is x cubed. What does x cubed parent function look like? It looks like spaghetti, right? And is that going to be even or odd, do you think? Probably odd. So I would probably check odd first. If I check odd first, that means f at negative x has to equal negative f of x. So I'm going to take f at negative x, so that's going to be a negative x cubed minus 1. Well, what's a negative times a negative times a negative? Negative x cubed minus 1. Box that in. Now do negative f of x. So I'm going to distribute a negative into the function. Negative x cubed plus 1. Are those two boxes equal? What did I just show you? It's not odd. It's not odd. So since it's not odd, now I need to check to see if it's even. If it's even, this box and this box should equal each other. Do they? No. So what can you conclude? This is neither. Do we understand that, yes or no? Okay, now there's one other concept I want to show you, and that is going to be when I give you an ordered pair. Now, if I give you an ordered pair, like negative 1, 3, and I tell you I want to make that an even function, where does the point negative 1, 3 go if it's even? I flip it over the y-axis. So if I'm flipping it over the y-axis, it's going to go over to right here at negative 1, positive 3. Do we understand that? If I want it to be an odd point, I have to flip it again, don't I? So remember, we look diagonally. So now the point 1, 3 is going to go down diagonally in quadrant 3 to give me what? Negative 1, negative 3. So if I'm even, only x changes. If I'm odd, x and y change signs. Do we understand that? Now look at tonight's homework. If you look at tonight's homework, problems 1 through 4, the graph is there for you. Problems 5 through 8, relatives max, min, increase, decreasing, constant. You have to graph it and give me that. Yes? Turn it over. Skip 9 and 10 for now. 11 through 16 is prove if it's even or odd, just like we just did. And then problems 17 through 20 is the ordered pairs that I just showed you. Any questions? Do you feel like you can do it? Yes? Okay, get this worksheet done. Tomorrow when you come back in here, we will go over problems 9 and 10 as the piecewise functions. Okay?